More to mass calculations. More to mass calculations. We'll be dealing with the questions whereby we'll be given the number of moles and will be required to convert those number of moles to mass. In this case, you'll be facing questions where you'll be given maybe just one quantity with a certain number of moles. Now, the question will be, how do you convert those number of moles to mass? So that's the reason why we are saying more to mass calculations. Remember again, my dear learners, I talked about the importance of this formula, number of moles equals mass given over molar mass. This is still very important because now we'll be relating the number of moles to mass, meaning what we are going to be using, we'll be using now the number of moles and the molar mass so that we can find the mass by multiplying the number of moles times the molar mass. So it's very important again, my dear learners, that you understand or you recall how we calculate the molar mass of the given substance. You can again go back, you watch my videos on how we are calculating the molar mass. Definitely, we are not going to waste time even in here because the concept is just that simple. So we are having an example. What mass of hydrogen, I am going to underline what they want us to calculate, meaning they want us to calculate the mass of hydrogen that can be used or that can be produced by reacting 6 moles of aluminium with hydrochloric acid. In this question, we cannot use hydrochloric acid because we don't know the number of moles. So we are going to use what we have to get what we want. So the quantities we have in this question is 6 moles of aluminium. So we are going to underline where we are having aluminium and where we are having hydrogen. I have hidden again the solutions given so that we can calculate this question together, and afterward I am going to review the answer. Now, this question is very simple because they have given us the number of moles of aluminium that reacted with 6 moles of hydrochloric acid as for us to produce 3 moles of hydrogen gas. This is what I'm talking about. So in this equation, we can interpret it as we need 2 moles of aluminium to react with 6 moles of dilute hydrochloric acid as for us to form 2 moles of aluminium chloride with 3 moles of hydrogen. Now, since this question is more to mass calculation, we are going to use the mass related to moles. So in question we have aluminium to hydrogen. Now, when you look at this question, they have given us the number of moles of hydrogen that was produced. So we are going to convert the number of hydrogen that was produced to mass by saying, since we have 3 moles, here we have 3 moles of hydrogen, we are going to say mass equals number of moles times molar mass. Remember, my dear learners, what I said. So, what are we going to do? We are going to say mass equals 3 moles times the molar mass of hydrogen, just hydrogen here, hydrogen. The molar mass is 2 times 1, so it will be 2 grams per mole. So we are going to say 2 grams per mole. So a mole and a mole cancel. So we are going to say mass equals 6 grams. So it is mass, mole to mass. So here we are saying we need 2 moles. When we react 2 moles of aluminium as indicated there, we are going to produce 6 grams of hydrogen. What if we use 6 moles of aluminium? What of 6 moles of aluminium? We are going to say X. So, what are we going to do? So, we are going to say X times 2 moles, we are going to have 2 more X equals 6 times 6, we are going to have 36 more grams. Okay, we are multiplying more times grams, so it will be more grams. So it will be over 2 moles over 2 moles. So our X will be equal to a mole and mole will go. So we are going to have 18 grams of hydrogen gas. So the interpretation here, my dear learners, is that 2 moles we are producing 6 grams. What of 6 moles? What are we going to produce? What will be the quantity of hydrogen? So we are saying the quantity of hydrogen will be 18 moles because we have increased the number of moles of aluminium. So when you look at how they calculated, or this question was calculated, I think it should be the same answer. So as usual, we are having 18 moles, 18 grams of hydrogen. So it's a very simple mathematics, and what is important is just for you to understand the concept. Nothing is very important than a concept. So here, questions should be very simple for you, my dear learners. So this is what we have as a relationship. Question number 2. Question number 2. How many grams of oxygen are required? Again here, we are going to underline the important points. We are looking for the mass of oxygen. How many grams of oxygen are required to react with 0.3 moles of aluminium to produce aluminium oxide? So we are not interested in the product. We are just trying to calculate the amount in grams of oxygen. So we are going to underline where we have oxygen. That is going to be required if and only if we use 0.3 moles of aluminium. Now, from the equation, we understand that if we have, for us to form 2 moles of aluminium oxide, we need to react 4 moles of aluminium with 3 moles of oxygen. Now, what will be the quantity of aluminium oxide if at all we use 0.3 moles? And what will be the quantity of oxygen which is going to react with 0.3 moles of aluminium? So again, we are going to say aluminium to oxygen gas. This should be converted to mass. So here we are going to say when we have 4 moles of aluminium, what is the mass of oxygen? That's the question. So we can calculate that mass. So we are going to say, okay, fine. Number of moles equals, or I can go direct by just saying mass equals number of moles times molar mass. Okay. Now, here they have given us the number of moles of oxygen that reacted with the 4 moles of aluminium, which is 3. So mass, when we have 3 moles times 32 grams per mole. I understand you know where 32 is coming from the molar mass. When we have oxygen like this, it means we have 2 times 16. 2, which is the number of atoms, times the atomic mass of oxygen, which is 16. When you multiply, you will find 32. So we are going to say more and more will go. So the mass of oxygen in this case will be 96. So we are going to say if we have 4 moles of aluminium, we are going to have 96 grams of oxygen. What if we have 0.3 moles of aluminium according to the equation? Here we are going to say X. So looking at this, we are going to say 4 moles X equals, when we multiply this, we are going to find, let me just confirm using the calculator. Using my calculator, when we say 0.3 times 96, we are going to have 28.8 grams more. So when we say over 4 moles, so our X will be the same answer divided 4. The answer will be 7.2, that is grams of oxygen. So meaning when we use 0.3 moles of aluminium, the mass of oxygen that is going to react with aluminium will be 7.2 grams of oxygen. So this is what we are supposed to do. So again, the question was answered and the expected answer, if it was calculated accordingly, it should be the same. So as you can see, we actually have that answer as the correct answer. Therefore, I expect you to be enjoying more concept calculations. So please, my dear learners, feel free to enjoy calculations under more concept. You are free to consult me, more especially those learners who have me as their tutor. Definitely you are free to consult me anytime. I am available. Actually, this is what I enjoy. I like to simplify work for my dear learners so that they prepare adequately for their exam. Looking at the exercise, as usual, I am not going to answer this exercise. Definitely what I can just do is to give you an expected answer if at all you are going to answer this question accordingly. So the question is, what mass of magnesium oxide will be produced when 0.5 moles of magnesium burns in oxygen? So when you do some gymnastics, you do some calculations, the expected answer of magnesium oxide that is likely to be produced when 0.5 moles of magnesium burns in oxygen must be 20 grams of magnesium oxide. Remember to construct a well-balanced chemical equation, because this is more to mass calculations and you must do it from a well-balanced chemical equation. Again, thank you so much, my dear learners, for following me. Don't forget to do the needful of subscribing. I love you. As you revise, you know, revise to be wise, otherwise no rise. Thank you so much.